Hi, this is the video lesson for lesson 12.7. In this lesson we're going to learn to solve exponential equations as well as logarithmic equations. This is Mrs. Lemke today. There are 3 warm-up questions. I'd like you to pause the lesson and do the 3 warm-up questions. Notice that the directions say write each of the expressions below with one common base and simplify. So I'll give you a little hint on number 1. You want to say, well, all of these are related to 3. So we'd have 3 squared for 9, 3 to the third, and then 27 is also 3 to the third, and then somehow simplify that using properties of exponents. Try those 3 and then come back. Okay, you should have done those 3 warm-up questions to the best of your ability. I have written my work minus the very last line of each one, or the last little bit. So in question 1, I had shown you this much. When you multiply, you need to add exponents. So that would be 3, and then I need to add 2 plus 3, which is 5, plus 3, which is 8. So 3 to the 8th could be my answer, or I could actually find 3 to the 8th. In the next question, you'll see that I rewrote both pieces to have a base of 2 because that is the common base. Both 8 and 4 can be written as a power of 2. So the 4 is 2 squared, and then I have this other exponent, and with a power to a power we multiply. And then when we multiply, we again would add those exponents. So we'd have 2, and then 2x plus, and then 3 plus 2 is 5. So that would be my final answer for warm-up number 2. In question number 3, the common base is 3. So again, I would write the 9 as 3 squared, and a power to a power means I multiply right here. And then when I'm dividing and I have the same base, I subtract exponents. So this should be your 3 answers for the warm-up. We're going to build on that idea today when we are solving exponential equations. We also will be solving some logarithmic equations. So let's take a look at the next part of your notes. It says evaluate the base 2 log of 16. Well, the way that I think of this is to write this is what I'm trying to find. So that's my x. And I rewrite it 2 to the x equals 16 in exponential form. And then I want to think, okay, I do know that 16 is related to 2. 16 is 2 to the 4th. And so from this line, I can deduce that because there's this powerful equal sign in between, and because these bases are already equal, that must mean that x is equal to 4, because in order for there to be equality here, these must themselves match since the bases match. We will use this idea in solving exponential equations whenever we possibly can. So in the first problem, we're already very much set up. We have a base of 3 that is the same for both sides, and this is a very powerful equal sign. Equals means things have to match. So if these already match, x minus 3 has to match that 5. So x has to be 8. Okay, next question. The bases are the same already. This is a very powerful equal sign, and so the exponents on the same basis have to match. So I get this, and that means if I rearrange things, x would be equal to 11. Okay? Moving along, question number 3 here is a little bit different than what we've seen thus far because the bases are not set up to match already, but think about what we did in that warm-up. Let's leave the left-hand side. Let's write the right-hand side like this so far. Can you think of what would be good to put in that slot, that blank? Right, so we want to have the common base of 2. 2 squared is 4. So we just replaced this 4 with 2 squared. Now we'll use properties of exponents on the right. A power to a power means I multiply. And we have the all-powerful equal sign. These already are equal, so the exponents have to be equal. So this would mean that x is 9. Okay, feel like you get that? If not, go back and watch it one more time. Make sure I'm not going too fast for you. For question 4, we want to write things with the same base. 2 is the base I'm going to use. How can I rewrite 32 with a 2? 2 to the 5th. Okay, so the 32 became the 2 to the 5th, and now I have a power to a power here. So 2 to the 4x equals 2 to the 5x minus 5. All powerful equal sign with matching bases. 4x has to equal 5x minus 5. And then we rearrange here, and we would find out that x is 5. Okay, on this one, our first move is going to be to get the exponential part alone because we haven't had a problem yet like this where there's just like this extra gunk in the way. And so we're going to just move that 3 to the other side, add 3 to both sides. Okay, I'd like you to pause and see if you can take it from there. Okay, pause and try number 5 on your own. Okay, hopefully this is what you have for problem number 5. Rewrite 25 as 5 squared. The exponents have to be equal. X would equal 0. There's another one that is a little bit tricky because we need to think of what our common base is. It's a 4. Can you think of how to rewrite the left-hand side as 4 to the something? 4 to the, well, 4 squared would be 16, and I want that 16 to be in the denominator. So 4 to the negative 2 is the thing, okay? That is equal to 1/16. So I have negative 2 equal to x minus 5, and therefore x would have to equal positive 3. Okay, to check my answer, just like with any algebra equation, I could plug in that 3 and verify that I did get an equation that works, a true equality. All right? The next that was the first category of problem we're going to do today, which is exponential, where you can get the bases to match. Here's a second category. This is an exponential equation, but you can't really get a common base very easily because there isn't a different way to write the 5. And 18, 5 to the something equals 18. That doesn't come out to something I know, right? 5 to the first is 5. 5 to the second is 25. There's nothing in between there to get that 18. At least not a whole number, I should say. So what we're going to do is use logs. I'm going to take the base 10 log of both sides. This is allowed because I'm doing something to both sides. That's true throughout algebra. I can take a square root of both sides. I can add 7 to both sides. Here I'm taking a log of both sides. The reason I do that is I get to use the best ever property of logs, which is that I can take this guy and put him down in front. So x times the log of 5 equals the log of 18. And now to get x by itself, I just need to divide. I divide the log of 18 divided by the log of 5. This is something I can do on my calculator. Just type it just how it looks on the page there. And you should get 1.79 to the nearest, I just rounded it, okay? So that's the idea. If you wanted to look at this more visually, and I am going to kind of just mention this in passing, if you take the function 5 to the x, which was this half of the equation, and you put that as y1, and then 18 you put in as your y2, what you're essentially doing is figuring out at what x value does this exponential curve cross this line, which is at 18. And the x value where those cross is about 1.79. Okay, so if you wanted to do this more visually, you certainly could. I actually think the algebra is faster, but if you needed a backup. Okay, we're going to use this technique now on the next several problems. Let's do this first guy together. So 5 to the 3x is going to equal, I'm going to move this to the other side, it's going to equal 10. Now that kind of looks like you could have related bases, but 10 is a multiple of 5, not a power of 5. So that actually isn't true. So what we're going to do again is use logs. So I take a log of both sides, just like so. All right, I use the best ever property of logs, the down in front, 3x times the log of 5 equals the log of 10. Now hopefully you guys know what the log of 10 is. If this is a base 10 log, I hope you all know that that right-hand side is actually equal to 1. And to get x by itself, I'm going to divide by the 3 and the log of 5. So I just need to type onto my calculator exactly what you see there. And x should be about 0.48, okay? Just to make sure you're good with the calculator piece, let's take a quick look at that. It would be 1 divided by, I'd use some parentheses here to show that everything I wrote in the denominator is where I think it should be. You know, I'm telling the calculator all that is in the basement. And then there's my decimal solution. And again, I rounded that to 0.48 on my paper, but whatever you need to do, okay? Next problem. Our first move is going to be to get the exponential piece on its own. So I need to move that 8 to the other side by subtracting it. And then I'm going to take a log of both sides. So log on the left and the right. Then use my properties. So I'd have 5x plus 4 down in front times the log of 10 equals the log of 27. What is the base 10 log of 10? Well, it's just 1, so that part doesn't matter. It's just a 1 being multiplied. So that has no bearing on our value. I'm going to subtract the 4. I'm going to divide by 5. So now I'm calculator ready. I would just type that in. Please go ahead and do that on your calculator and make sure that you get this decimal. You can pause it if you need to do so, okay? But make sure that you do know how to do that on your calc. Okay? Let's take a look now at, actually I'm going to end this video right here because I'm getting a little nervous about length, okay? This is a good stopping point. So this part will be just on exponentials. There'll be a second recording that is about log equations. That's what the rest of your note sheet is about.